Good afternoon to all of you. Myself Tina Kathpal, lecturer in chemistry from Pandit Jagat Ram, Government Polytechnic College, Hoshiarpur. Today the topic of my presentation is the concept of oxidation and reduction. Basically, oxidation and reduction are the two processes which can be explained according to two concepts. First one is classical concept and second is electronic concept. Let us discuss these two concepts in detail. First is classical concept. First of all, let us define oxidation according to classical concept. It is defined as the process which involves addition of oxygen or removal of hydrogen. So basically, oxidation is that process in which either oxygen is being added or hydrogen is being removed from a substance. It can be explained by taking few examples. For example, when sulfur reacts with oxygen, it forms SO2. This example clearly shows the addition of oxygen. Similarly, when carbon reacts with oxygen, it forms carbon dioxide, that is CO2. Again, it is an example of addition of oxygen. In the third example, H2S reacts with Br2 and result in the formation of HBr and sulfur. What happens in this reaction? That actually hydrogen is being removed from sulfur. So we can say it is an example of oxidation in which hydrogen is removed. Now, what is oxidizing agent? A substance which supplies oxygen or removes hydrogen is called oxidizing agent. So, any substance which is supplying oxygen for the process of oxidation or it helps in the removal of hydrogen, that is called oxidizing agent. It is also known as oxidizer or oxidant. For example, in the shown reactions, O2 and Br2 act as oxidizing agents. As we can see here, oxygen itself provides oxygen for its addition, and here Br2 is used for the removal of hydrogen. That is why in these cases oxygen as well as bromine act as oxidizing agents, also called oxidizer or oxidant. Next is the process of reduction according to classical concept. It is defined as the process which involves addition of hydrogen or removal of oxygen. That means it is just reverse of oxidation. Here what happens? Hydrogen is being added or oxygen is removed from any substance. Again, we can explain the process of reduction by taking few examples. In the first example, hydrogen reacts with chlorine, resulting in the formation of HCl, that is hydrochloric acid. This is example of reduction where hydrogen is added to chlorine. Similarly, in the second reaction, hydrogen combines with bromine and gives HBr. Again, it is addition of hydrogen, so called reduction. In the third example, you can easily see that it is a removal of oxygen, means in this case zinc oxide reacts with carbon, resulting in the formation of zinc and carbon monoxide. Here what happens, this carbon helps to remove oxygen of zinc, that is why after this oxygen has been removed from zinc. So, it is an example of reduction where removal of oxygen takes place. Next is reducing agent. Again it is just reverse of oxidizing agent. A substance which supplies hydrogen or removes oxygen is called reducing agent. There we said oxidizing agent supplies hydrogen, here reducing agent supplies hydrogen and it removes oxygen. This reducing agent is also called reductant, or sometimes it is also known as reducer. In the above examples, H2, that is hydrogen, and carbon act as reducing agents. Let us see these examples again. Here you can easily see that this hydrogen is being added. So, this H2 act as reducing agent because it provides hydrogen for its addition. Similarly, in the third example, as I have already explained, that this carbon helps to remove oxygen from zinc. That is why it is also acting as reducing agent. Now, let us come to the next concept, that is electronic concept. First we will discuss oxidation according to electronic concept. It is defined as the process in which an atom or an ion loses one or more electrons. So, it is the process, in short we can say, where loss of electrons takes place. So, simply when any atom or ion is losing electrons, the process of oxidation is taking place. What happens after oxidation? The loss of electrons either increases positive charge or it decreases the negative charge of the atom or ion. So, after oxidation, either there is increase in positive charge or there is decrease in negative charge of the atom or ion which is undergoing oxidation. It can be explained by taking few examples. Examples showing increase in positive charge. When magnesium undergoes oxidation, that is it loses 2 electrons. After the loss of these 2 electrons, it changes into magnesium 2 positive ion. Here you can easily see that there is increase in positive charge of magnesium. First it is having 0 charge and after oxidation it acquires +2 charge, that is charge is increasing from 0 to +2. Similarly, in the second example, iron 2 positive changes into iron 3 positive, that is there is change from +2 to +3, that is again there is increase in positive charge from +2 to +3. Now, I am giving you the examples which show decrease in negative charge. So, after oxidation, that is after the loss of electrons, there is decrease in negative charge. For example, when sulfide ion having -2 charge undergoes oxidation and it loses 2 electrons. After this process, it acquires zero charge, means there is decrease in negative charge from -2 to 0. Again, in the next example, MnO4 2 negative after the loss of one electron changes into MnO4 1 negative. Again, there is decrease in negative charge from -2 to -1. And the substance which loses electrons is called reducing agent, means the substance which is undergoing oxidation, that is called reducing agent, means reverse is there. The substance undergoing oxidation is known as reducing agent. Next, let us define the second process, that is the process of reduction according to electronic concept. It is defined as the process in which an atom or ion gains one or more electrons. That means it is again reverse of reduction. There we said that the loss of electrons takes place, but here the gain of electrons takes place. And after reduction, what happens? The gain of electrons either decreases positive charge or increases the negative charge of atom or ion. Again, reverse case is there, that after reduction either positive charge decreases or the negative charge of any atom or ion increases. Again, I am giving you the examples which can explain this statement. First, examples where there is decrease in positive charge. For example, when ferric ion having 3 positive charge gains 1 electron, after this reduction it acquires +2 charge, means the positive charge has been decreased after the gain of 1 electron. Similarly, in the second case, when tin having 4 positive charge gains 2 electrons, it acquires 2 positive charge, means again the charge has been decreased, positive charge from +4 to +2. Next examples show increase in negative charge. Here I am taking the reverse reactions of oxidation, that sulfur when gains 2 electrons, it changes into sulfide ion with -2 charge. That means there is increase in charge from 0 on sulfur to -2 on the sulfur atom. Similarly, here MnO4 having 1 negative charge after the gain of 1 electron acquires -2 charge. That means negative charge increases from -1 to -2. And the substance which gains 1 or more electrons is called oxidizing agent. And the substance which is undergoing reduction is known as oxidizing agent. So, this is all about the process of oxidation and reduction according to classical as well as electronic concept. Next, let us explain the statement that oxidation and reduction are complementary. Complementary means they occur simultaneously, or we can say that they always occur side by side. It is observed that neither oxidation nor reduction can occur by itself. A substance which can lose electrons only if there is another substance to gain those electrons. So, loss occurs only if there is gain of electrons. So, we can say that oxidation occurs at the cost of reduction and vice versa, means if oxidation is taking place simultaneously reduction will also be taking place, and none of the reaction can occur without each other. So in short, we can say that both oxidation and reduction go side by side, means they always occur simultaneously. I am giving you an example which can explain the same. This can be explained by taking the example of magnesium, that when it is burnt in the presence of oxygen, reaction is magnesium reacting with oxygen, forming magnesium oxide. This is basically a reaction which involves both of the processes. Now, what happens in this reaction? It takes place in two steps. In the first step, magnesium undergoes oxidation. Oxidation means it loses electrons as shown in this reaction. That magnesium, after the loss of these two electrons, changes into magnesium ion, and this process, as we have already learned, that it is oxidation. Now, question is that where these two electrons have gone, means after the loss of electrons, where these two electrons have gone? Have they gone into air or anywhere else? Let us see. What happens? Actually, these electrons are accepted by oxygen, which changes into oxide ion as shown. Here, one atom of oxygen will gain these two electrons where these are lost by magnesium, and after the gain of two electrons, it changes into oxide ion, that is O2 negative ion. As one atom of oxygen needs two electrons for the formation of oxide ion, but as we already know that oxygen always exists as O2. So, two atoms of oxygen will require 4 electrons for reduction, and they will change into 2 oxide ions. So, that means reduction is also taking place at the same time. Now, if we add these two reactions, that is this reaction of oxidation, first of all you multiply this reaction by 2 so as to make the number of electrons the same, and then if we add oxidation as well as reduction, you will get the net reaction. So, in short, we can say that both oxidation and reduction are complementary to each other. In this example, magnesium loses electrons, means it is undergoing oxidation. So, it will act as reducing agent. On the other hand, oxygen, which is accepting the electrons and undergoing reduction, that will act as oxidizing agent. So, you can easily predict from the reaction that which is oxidizing agent and which is reducing agent in that particular kind of reaction. Now, next one is redox reactions. This word redox is made up of two parts, that is red plus ox, means reduction and oxidation. So, such reactions which involve both reduction as well as oxidation are called redox reactions. That means the reactions in which both oxidation as well as reduction are taking place, they are known as redox reactions. Next is types of redox reactions. Basically, redox reactions are of two types. First one are direct redox reactions and indirect redox reactions. We will study about these two kind of reactions in detail. First, I am going to tell you about the direct redox reaction. What do you mean by the word direct? Let us see. The reactions in which both oxidation and reduction take place in the same vessel are called direct redox reactions. Means both oxidation and reduction are taking place in the same container, you can say in the same beaker. That means they are indirectly contact with each other. That is why they are known as direct redox reaction. Clear? So, let me tell you again, the process in which both oxidation and reduction are taking place in same vessel and they are in direct contact, that kind of reactions are known as direct redox reactions. An example of direct redox reaction is zinc rod dipped in copper sulfate solution. Here you can easily see this diagram. The first diagram is before the start of experiment. Here what are you seeing? That there is a rod which is of zinc and it is placed in a beaker which contains a solution of copper sulfate. So, what happens after some time? This second diagram shows the diagram after few minutes or after your observation. So, this is diagram just at the start and this is after some time. Now, tell me what is the difference between two? Let me tell you that what happens after some time. A part of zinc metal has dissolved and has lost its weight. Let us see from the diagram. Here zinc rod is fully solid rod and after some time you will see that it has lost its weight and has been eaten away as I have written in this diagram. Secondly, what you will observe that reddish metallic copper has started depositing on zinc plate or setting at the bottom of beaker. So, after some time some particles will settle at the bottom of beaker. Thirdly, bluish color of the solution gradually fades away. As we know that copper sulfate is a blue colored solution, this blue color will fade away after some time. Solution becomes hot after some time and solution remains electrically neutral. So, these are the few observations which we will observe after few minutes. Now, let us explain all these observations one by one. In the first step, zinc loses 2 electrons to form zinc ions, that is zinc undergoes oxidation, as you can easily see in this reaction. After the loss of 2 electrons, zinc changes into zinc ions and these electrons will move into solution. What happens in the solution? As we know that there are present copper ions from the copper sulfate solution. These copper ions gain 2 electrons to form solid copper and reduction takes place as shown in this reaction. So, after reduction, copper solid is being formed which settles at the bottom of beaker or it will start depositing on the zinc rod. So, explanation is also like this: when zinc rod is placed in the solution of copper sulfate, zinc loses electrons to form zinc ions and copper ions gain these electrons to form copper metal as reddish precipitates, as I have already explained. As a concentration of copper ions present in the copper sulfate solution decreases, the blue color of the solution fades away. As we know that blue color of the solution is basically due to copper ions. As the number of copper ions are decreasing because they are changing into copper solid during reduction, then due to decrease in copper ions, the blue color of the solution becomes fade, and we can also write the overall reaction, that is zinc is changing into zinc ions and the electrons lost by zinc are captured by copper ions of the solution and change into copper solid. So, these electrons are transferred from zinc to copper ions directly. That is why this kind of reaction is called direct redox reaction. Next, let us study about indirect redox reactions. The reactions in which both oxidation and reduction take place in different vessels are called indirect redox reactions. In case of direct redox reactions, I have already told you that they occur in the same vessels, but here the case is different, that both oxidation and reduction are occurring in the different vessels. And a very common example of indirect redox reaction is electrochemical cells. What is an electrochemical cell? It is that cell in which the chemical energy is converted into electrical energy. Here, this diagram shows an electrochemical cell. Let us read about its construction. In this cell, zinc sulfate solution is taken in a beaker and zinc rod is dipped into it. This beaker, that is the beaker present on left hand side, contains the solution of zinc sulfate and its concentration is 1 molar, and this solution, in this solution a rod is dipped which is made up of zinc. Similarly, copper sulfate solution is taken in another beaker and copper strip is dipped into it. Similarly, in this beaker, a solution of copper sulfate has been taken. Again, its concentration is 1 molar and a rod of copper is dipped into this solution. These two electrodes are connected to each other by wires, and in the center a voltmeter is connected which will tell us about the flow of electrons and hence about the current. An inverted U-shaped tube containing concentrated solution of inert electrolytes such as KCl, KNO3, etc. connects the two solutions. Here you can easily see that an inverted U-shaped tube is there which is filled with some electrolytes, and these electrolytes may be KCl, KNO3, etc. And this tube is called salt bridge. What happens and what we observe during this setup? There is flow of electric current through the external circuit, means there will start current in this external circuit zinc rod loses its weight while copper rod acquires weight. Again, what happens? That this side of beaker, zinc rod will lose its weight and copper rod will gain weight after some time.